Alright, in this video, we're going to go over what's really going on in the air, or whatever medium a sound wave goes through. What is really going on with those particles when I speak between my vocal cords making the noise, the vibration in the air going to the camera. What's going on in this space with the air, you know? Let's talk about that with sound waves, okay? What does the wave look like? We have been drawing sound waves like this red drawing with crests and troughs, but to be honest, I can't see that going on between my face and the camera. It looks more like a water wave. It's a transverse wave where the particles go up and down while the wave goes left to right. Alright? And I don't really see this happening in the air during a sound wave, or even in the water from sound waves if I talk underwater when it sounds all garbled. I want you to copy this down. This is a representation of a sound wave. Copy all of it down. And it's not exactly what's going on in the air, but there's still a reason why we draw it like that, and we'll get to that by the end of this video. So I'm going to pause while you copy down, and then we'll start again, okay? Okay, so sound waves is our title. Put a date on it, and this picture up here of the dots is more accurate representation of what's really going on in the air right now from a sound wave. The dots are meant to represent particles, okay? Each dot is an air molecule. And we can see there are areas where, over here, 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 and here, where those molecules are packed close together. They're compressed, pushed together. So we call those areas compressions. Write that down. It is a high pressure area. Okay? And the spaces between the compressions are places where there is low pressure. There's less molecules of air there. Okay? So those have a special name, which you have not heard before, and it's spelled it's called a rarefaction. R-A-R-E-F-A-C-T-I-O-N. And it is a low pressure area. Alright? Now, over here would be where we have a source of sound, maybe a speaker you could draw. And then the wave travels from the left to the right. And over here, we have something like an ear. There's my bad drawing of an ear. And when you have a high pressure area, compression right next to your ear, you could feel it, especially if it's loud. And those air molecules are bumping into your eardrum, and that's how you perceive the sound, okay? So what are the particles doing to make compressions, the high pressure area, and then rarefactions? Well, like we talked about in our longitudinal wave video, the particles move like a pendulum. They move in and out, back and forth, back and forth. The particles over here next to the speaker do not make this long trek all the way to the ear. Each particle over here bumps shoulders like a pool ball on a pool table, bumps into the next pool ball and into the next pool ball and into the next pool ball, and there's basically a shoulder to shoulder chain reaction of one air molecule hitting into the next, hitting into the next, hitting into the next, that transfers the wave from the source, which is the speaker, to the ear. Okay? The particles over here do not walk all the way to the ear. The particles by my mouth, the air molecules, do not walk all the way to the foam that is listening. There's a chain reaction. One bumps into the next, into the next, into the next, into the next, until it reaches whatever's listening. Okay, so the particles move in and out, which is parallel to the way the wave move, which is left to right. The particles don't go up and down like water molecules. All right, that would be a transverse wave. If the particles went up and down, then particles move in and out, and that in and out bumps into our eardrum to make us feel pressure and then perceive sound. Okay, so the fact that the particles go parallel to the way the wave moves makes it a longitudinal wave that they move in and out. Okay, sound is a longitudinal wave. It's a pretty cool idea that it's just a chain reaction of one molecule bumping and pushing into the next, and then the last molecules bump into our ear, and that's it. You know, that's really it. Okay, so this picture, why have we been drawing sound waves like this? You drew loud ones with higher amplitudes. You drew compressed ones with higher frequencies. Why have we been drawing them like this? Well, it's just really a pain and annoying to draw a million dots every time. That's the only reason. So we're going to continue to draw sound waves like this 99% of the time. Even though it's not sounds longitudinal wave. Why are we drawing a transverse wave? Well, it's just easier to do it, and just remember that it's longitudinal because those movements are parallel. Okay. So the crests just represent compressions when we draw it like this. So this right here gets represented by a crest. Another compression, another crest. Another compression, another crest. Another compression, another crest. And the low pressure areas without a lot of molecules in them are going to be represented by troughs. Here, here, and here. So this is a nice way to take this picture and make it into much easier to draw right here. Okay. So if you had more compressions packed close together, you would just have a packed close together wave here. And you would be a higher frequency wave and higher pitch, all right? So you could draw another compression here, here, and pack them here, pack them close together, and you have a high pitch, high frequency wave. If the compressions have more molecules in them, then they are higher pressure. If each compression has more molecules in it, then you just have a louder wave, okay? And then you would draw each of these as a higher amplitude. Okay, and that would represent loudness. All right. So, how do I make this picture louder? Make it taller. How do I make this picture louder? I just literally put more molecules, make a higher pressure. Eventually, that pressure will get so great that it'll hurt. Be 140 decibels or something like that. And if I keep drawing more molecules in the high pressure areas, might get dangerous.